Solids, right? We played with all kinds of fancy solids. We did round solids. You got shafted. We did rectangular solids, and we pulled on them, and we drilled holes in them, and we put notches in them, and all kinds of fun stuff, right? And then we did shells, right? We did shell elements. We did pressure loads on them, but actually shells are probably most commonly used without pressures on them, because we just don't see all that many pressure loadings. I gave you the two that we tend to see, but we tend not to see all that many pressure loadings. But we do use shells an awful lot. Anytime we have things where the one aspect is very thin compared to the other, right? It's advantageous to use shells. They actually do better accuracy. So we went from 3D elements to 2D elements, and now we're going to 1D. Okay, so hey, the models even get easier. Okay?
What?
Do they actually?
The models even get easier.
So
right?
we're gonna draw a line?
That's, what can I say?
So we just have to look at someone else? That's it? You did beam analysis?
Today we're doing beams. Okay? I'll even get, okay?
Actually using the beam function, right?
We're doing beams. So, to quote somebody else, what old television shows, beam me up, Scotty. Which means nobody's paying any attention to me. Okay, so we're playing with beams these days, and so what we're going to do is we're going to model some beams. Okay, so I give you a beam problem.
We did the second one already.
You know, I actually realized that.
Sorry.
And I intentionally picked that problem because of that. Because guess what? I thought, you guys are getting all tired here. Well, I'm going to give you one you've already done the manual calculations for.
You're the best.
Yay!
Okay, so am I not nice?
Super nice.
Okay, so.
Thank you, Bashara.
Okay. And he was a bit aggressive about that the first time, right? So now we're going to do that one with beam elements instead of with solid elements like we did it the first time. Okay? Does that make some, did that resolve that particular issue there? So as I give Bashar a bad time here. So, okay, so anyway, we're going to do this one here. So what do we have? We have a nice beam here, simply supported. Does it get any easier? It's straight. Okay, and we have, it's a W12 by 22 beam. Standard cross-section. Just go down, call them up on the phone, Everett Steel or Far West or your steel supplier of choice, and go, give me one of these. And they're going to go, yes, write us a check, and they will drop it off, and then you get to go deal with it. Okay, right? And everybody knows what the specification means. All right, you all remember 12 by 22?
Yes.
Means it's
12 inches tall and 22 pounds per foot.
That's the construction engineer in you, right? Or was it with construction engineer?
Yeah.
Okay. Oh, okay. Sorry. Absolutely. It's 12 inches in the principal dimension, which in this case is obviously the height, and it's 22 pounds per foot. So that looks like a 10-foot beam weighs 220 pounds. Okay, we gonna buy that? If we're gonna put 8,000 pounds over here and 5,000 pounds over there, which means we're putting 13,000 pounds on it, do you think we need to worry about the weight of the beam?
No.
I suspect that it's, since we have 13,000 pounds on it, it's slightly over 1% of the load, right? I don't trust my answer to 1%, right? So I'm not going to worry about the weight of the beam. We can if we want to, but it doesn't really matter, right? Okay. So, again, can I get a simpler one than this? Okay. You're not, there's skepticism in this classroom here. I must have earned this. Lots of hard work and effort here. So, okay. So how are we going to model this? Well, the first thing is, okay, so we get SolidWorks up and we go, I want a new model. I'm going to get a new part here, right? And we go with a new part. And okay, how am I going to model this? Well, in SolidWorks, there's I'm going to model this as a center line. So I'm going to pick on the front, not the top plane, the front plane. Actually, I could pick on the top plane, doesn't really matter. But the front plane works better for this. Or I'm going to sketch this, and I'm going to have some line that I'm going to draw. Yeah, shut up. Okay. So I got a line that I'm drawing. I'm going to dimension the line. I'm going to say 144. And then I'm going to click on the line here and 0 on the line. Okay. And I have a 144-inch line, and now I want to make that a beam. Okay. And in SolidWorks, that's how we do that, is we select the line, or the one we want to do, and we go to Insert, Weldments. Okay. I got to get out of the sketch. That always is my shortcoming. Insert Weldments, and it gives me a choice of a weldment or a structural member, and we want to do a structural member. Okay, now when you come up, yours is going to look different than mine. Yours is going to have something that says ANSI inch or ISO, right? And if you click on ANSI inch, which is the only one here, you're going to click underneath it, you're going to see some things that look like this, where it says angle iron and pipe and rectangular tubing and square tubing, and it'll also say C sections and S sections and a few others in there, if I recall, right? Right? But there is a shortcoming here. It doesn't say W sections. You can go, well, S section's close. No. And mine doesn't even say S sections anymore. So, okay. Now you're going to have to do something at home. Because if all 1, 2, 3, 4, 5, 6, 7, 8, 9 of you tried to download several megabytes of data files all at the same time, the poor little router in there is going to run to its knees. Okay? So, the way this works is that SolidWorks has created all of the sections and all of the things for you, but they're out in a design library. And so you have to download them and install them in the appropriate place. Okay, it's not hard to do, but you got to do it. Okay, and so the way this works, I'll find first of all where you get them from. So you can go over to the design library over here, and under the SolidWorks contents, right? So there's a whole bunch of things in there. SolidWorks content down here at the bottom, and under that is weldments, and under weldments there's a whole bunch of things. If you click on these, you will start downloading them, and then of course it's like 3 megabytes each. Now maybe we can get by with all 3 megabytes. Somebody's going to click on it anyway, I know that for sure, right? And start downloading because they're going to go, I'll do it while nobody else is, right? Okay? Because there's going to be plenty of bandwidth for that, and it's not actually all that bad. You could probably get away with it a little bit. So anyway, ANSI inch here. And it will ask you, you control click, it'll ask you where to put it, and it's a compressed file, and you save it somewhere. Okay, I don't care where, save it somewhere. Okay, on your files, wherever it happens to feel like, save it there somewhere. It'll be let me see if I can't go find it here. Let's see, which one is it? Yes. Mine particular one got put under downloads. And here's ANSI itch zip, which is 31 megabytes. Okay? And I uncompressed that, so it's 31 megabytes times 10 is 300 megabytes. Actually, it might not be all that bad on if you guys start downloading it. Anyway, this is what we need. The ANSI inch here, this is what it does. Now, you'll get this ANSI inch folder here, right? Or you extract it out. You might want to do something with, like, rename it ANSI inch 2, just so it's a different name and it doesn't erase your current file. Now, so far, all I did was download it and extract it, right? That's all I did. Downloaded and extracted all 30 megabytes of it or whatever it is. Okay, it's downloaded and extracted. Now you have to put it where SolidWorks can find it. You would think they would make this easy. I suspect Katia does a pretty good job of this. SolidWorks does not. Okay, can I say nasty things about SolidWorks? Yes. Okay. In order for SolidWorks to find this, when you're using the model, it has to be installed in a particular directory. Basically, you are building a subdirectory tree, and you need to put it in a particular location. Okay? The location that you need to put it in, okay? And I will, is not under anywhere nice. To tell you this, it's on C, right? Under C, under Program Files. Okay, SolidWorks Corporation, SolidWorks, and now, so far you can kind of go with it. Okay, we've gotten into the SolidWorks directory, right? It's under Program Files, still a stupid place to put it, but that's where it is. Okay, now life gets interesting. It goes under language, English, weldment profiles. When you get to there, yours will just say ANSI inch and ISO. So the place you're getting to is this path here along the top. Program Files, SolidWorks Corporation, SolidWorks, Lang, English, weldment profiles. Okay, everybody get to there?
No, sir.
Okay. So, and you will just have the two, ANSI inch and ISO. Okay? This is where you need to put that file. You need to put your file in here. When you try to copy it in, it will whine at you. Windows 10 will whine and say, you need administrator privileges to do that. And you will say, I'm administrator. I'm master of my domain, shall we say, okay? And you'll copy it in there anyway, because it's obviously it's in anything in the Program Files directory, it's wanting you to have the administrator to change. Okay? What they do is they build a hierarchy in here. They build a hierarchy of sizes and types. There's a directory tree that starts under weldment profile. And this is where everything goes. Now, I just added one in that was ANSI inch 2, right? The ANSI inch 2 was the one I added in. And I actually added the other ones. The ISO one, you can see, was when I installed SolidWorks, was in February, right? That's where I installed it. But the other one got edited because if you don't rename them, it will write over the old one, which is, okay.
I thought I renamed it.
Yeah, it really requires a pretty good rename. I thought I had renamed it too, and it.
So I just did ANSI inch 2, like you did.
Okay.
And I said extract to that location, and it just copied over ANSI inch.
Okay.
So how do you have to reinstall it?
You just don't worry about the ANSI inch, just let it go. There wasn't a whole lot in it anyway.
Okay, so you're okay.
Oh, God. I don't have to make anything with it. Okay, so, okay. It is fussy. It did the same thing to me, so. And actually, it's not terribly bad. If you look at the ANSI inch one, the ANSI inch 2 one, this is what it gives you. This is the contents of the ANSI inch 2 directory. I have a whole bunch of things that say AL and channel, CS channel, beam standard angle, LS angle, pipe, structural, round tubing. What are all these gonna be up here? They're all ALs. They're aluminum, right? These are all aluminum cross sections. And then there are some like C channel and S section, which were I think I wrote over, right? Those were the ones I wrote over. If you wrote them, the other ones like pipe and the others will all be in there. So, and they may have been all in there. These are all there, and you can tell when I created mine. Well, I created mine at 1 o'clock this afternoon. So.
Oh, they
Okay.
just added it to the.
Yeah, the others are there, I think.
Yeah.
The others are, if you look at the dates, the others are still there, right? So I think you're okay. Okay, so down here, of course, we have
W section.
W sections. And we actually have more pipes because there's not very many in the existing pipe model. If you go in and look and I'll go back and look at yours. Here's what ANSI, see, I have, if you look at pipe in here, there's only three sizes of pipe, right? I've got what? Half inch, inch, and inch and a half pipe. And if I go over to SolidWorks and I pick on pipe, what sizes do I see? I see half inch, inch, and inch. See, we're replicating that directory tree, right? Over here in our selection mechanism, we've replicated the directory tree that's over here, right? Okay? So we've just, and it's only allowed 3 levels, and it has to have 3 levels, actually. Okay, Tom.
So when we extract, that's what we have to extract it to?
That's, well, yeah, well, I would extract it first and then copy it, okay?
Copy, and then
Because when you do the copy, if you do the extract of that, well, depending on how it does, it may mess with the permissions, right? Because there's the administrator permissions to write in that place. However you get it there, I don't care.
So-
As long as it's there, you're fine, right?
So if we were using pipe, a 1-inch pipe, we would actually click on the 1-inch pipe in there.
That's right. Well, when you click on it in SolidWorks, and it'll make it 1-inch pipe.
Okay, and then
Okay.
when we save it to this file, are we saving it to a folder or inside that? Where are you saving it?
Well, what we want to do is we want to save our ANSI 2 thing here, which is this one here. See, this one here wants to get saved to this directory.
Okay.
SolidWorks Corp, SolidWorks Lang, English, Weldment Profiles, and whatever name we have. I've got 4 names here, right? ANSI, and then there was only 2 originally, right? There was ANSI Inch and ISO, right? And so I have added the ANSI Inch 2 one and the custom one, which might be an indication of what the second part of the assignment is, right? Okay, I mean, just to give you a little heads up, right? Okay, so that's where we're going, right? Which makes, I think, a certain amount of sense. We're going to go play with weldment profiles today. So what I want to do is I want to get back here. I'm going to go pick on my ANSI Inch 2. I'm going to go do the weldment section, the W section, and I'm going to do W. I can scroll down here to W10, and I'm going to pick a different one just because I'm that kind of guy. Let's pick a 10-inch one here. Why not? Okay. Okay, I'm going to pick 10 by 19, and I say okay. Well, first of all, you need to pick on a group. And the group is which one I want it to join to, and it's going to go, oh, that's what we did. All of a sudden, magic happened. I pick on a group, and it built me an I-beam. There's only one minor problem, or W section. It built it in the wrong orientation. It built it flat.
Can you just
which I'm cursing, but there is an angle down here on the lower left. And I could say 90 degrees, and it'll go, oops, 90 degrees. And I don't know about you, but it looks like we have a W section.
So are we all supposed to have W section option under type? 'Cause I don't have.
Not till you download it, not till you download all the others, right? Because now all you have is an S section, which is close, but it's, what's the difference between an S section and a W section?
One begins with an S, one begins with a W.
I can tell he works in IT. Okay. So it's that Microsoft help answer, as I refer to it as. Yes. The technically correct and completely useless, right? So okay. So that right. No, the S sections, the inside is tapered like a channel, right? They're what our traditional I-beams are. Originally were considered S sections. The inside flanges are not flat, they're tapered. And that's because when they first started rolling them, that's all they knew how to do. It was hard to do the flats. And so they rolled them with tapers on them, right? So that the inside was tapered like a channel iron. They have an angle, not a very big angle. It's like 15 degrees, but there's an angle on the S sections. The W sections and the HP sections and some of the other more newer sections are all, the flanges are all flat. They're all constant thickness all the way across. And they're the ones that we all use these days. They're much cheaper than the S sections for a variety of reasons. So we do this. So anyway, okay, you can go pick on an S section if you want to follow along. We can pick on an S section. Later you can just go back and change the profile and it'll all work, right? Or some of you. What's that?
It
Would
should
it work?
just come up.
You can just pick an S section.
It should just come up once it's in the flange one.
Yeah. Well, all you do is you can go in, if you want to, you can go ANSI inch and pick a, well, I don't have S section over here, but I can go to, because it got eaten by my other topic. I can go to S section here and I'll have ones that looks like, well, I got a whole bunch of them here, but the ones at the top are yours, right? You have 3.57, 4.77, and 5.10, right? That's the ones that you had in yours. It just added on to them. So if I pick that one, right, what's it going to do? It's going to give me that beam. And you see, if I zoom in, see how they're tapered? Yeah, it's an S section, right? Okay. So I don't mind that one. That's a fine beam to have. We'll just put that. I mean, to change it, all you have to do is go and edit the object, right, and go back in and change it. It's an easy thing to change at the next time through once the model's built, right? It's not hard to change. Does it make some sense there? So you can build it out of anything proper, and then when you want to go back and when you have the new profiles installed, you just go back and reload it and change it, and you'll be there. Okay, is that good?
Yeah.
Okay, so I'm going to say okay. I've got an S section here. I like my S section. It's actually cool. Okay, so now I've got a perfectly fine section here. I'm going to go do the simulation, new steady. I'm going to go beam me up. Okay. Okay. And now we're going to go, of course, define some material to this. And because I don't know any better, I'm going to say it's A36. Okay. Some nice steel. One of the things you should notice here is that when it created this beam and we went into the model, there are two big balls here. See these big balls? Okay. And Brian. Always one or two in the or two in the class, as I say. Yes. Okay. 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 So yes, and I'm going to have to. Okay. So I'm going to have to be careful here now because I'm going to start laughing too badly here. So okay, we're tough. Okay. So anyway, we have these. These are indications of what it calls joints. When SolidWorks makes a model out of beams, it puts joints at the ends of it. There are places where other things can join to. Okay, and so it indicates where the joints are in your beam model with these balls. Okay, and so we have these. This is a place where we can apply constraints to. We can apply loads to them, we can apply displacement constraints, other things. So let's go apply displacement constraints. You notice we got very little choices here. We got fixed geometry, so okay. I don't really want fixed geometry, but immovable is not a bad choice. And you notice the only thing I can pick on here is this little symbol over here, which tells me the only thing I can apply my displacement constraints to is the joints. I can't apply them anywhere else. So if I want to apply them in some particular place, I have to make a joint there, okay, to be able to do that. Okay, so I'm gonna actually do immovable, which is no translation. I don't want to do a fixed geometry because that supports that supports a moment, right? I don't want to support a moment. So I'm going to do that, and I can just click on this ball over here, or I could even get somebody's favorite guy up here, right?
Oh.
Okay, so that, and I have the one that's I have guys on the end here, right? And I can make the arrows big so that everybody's happy, right? Okay. So I've got one end fixed, and now if that was good, I can do it again. Now I can't make this one immovable because it's a roller, right? And it doesn't want to support a, it's allowed to move in the X direction in this particular case, right? So we need to support it in the Y direction and the Z direction. So I'm going to do the use reference geometry here, which is always a good one. I'm going to pick on this other end over here. I'll rotate it around a little bit. I tend to like to pick a plane that makes myself convenient. So in this particular case, I'm going to use the right plane for the coordinates, because if I fix the in-plane ones, and I'll make the arrows big again, right? How come it's not showing me the preview there? Okay. That's stubborn of it. Oh, I had collected those. Okay, there we go. I didn't want the rotation components, I wanted the translation components. I did select them. Darn thing is stupid as can be. Ag, SolidWorks. Okay, so I have these two displacements on the ends. It's supported in the vertical direction, and it can't move out of the plane, right? Those are the two constraints we have on it, right? So we can see it's supported this way, it can't move out of the plane. This one's supported in all three directions. Okay, that's good, isn't it? Easy peasy. Can it get any easier? Okay, now what do we do? Loads. Okay, so let's look at my problem. Right? What did I have? Ooh, I didn't. Who needs handouts? There's some. Oh, we got handouts. Yes. Okay. Okay, so it looks like I need to put. Ooh, did I forget? Did I hand one? Oh, sorry. I didn't realize Syra didn't. Syra grabbed it. Oh, okay. Okay. So now you have two there, Jimmy. We have to give Syra a bad time there. So okay. What are we doing now? It looks like we got to move over here. We got 4 foot of 5 kips load and 4 foot of 8 kips load. Okay, and so I go over to my model and I go, okay, let's put some loads on here, and I want to put a force, and it goes, well, I've got a choice of vertices or points, or I can put it on joints, or I can put it on the beam. So I go, I'm going to put it on the beam, and it looks like when I click on the beam, I get the whole thing, which you sit and look at and go, expletive deleted. Did that instructor really do that to me?
Yes.
And the answer is, of course, yes. So what do we have to do? Well, okay, I split it and I look up here and all those tags for splitting aren't there. So, okay, yeah, darn it. So what we have to do is I'm gonna have to go back to my model and edit the sketch. And instead of 44, I'm gonna make this something like 48, right? And I'm gonna get Brian's favorite thing up here. And then I'm going to draw another line.
Oh no.
And then I'm gonna draw another line, okay? And then I'm gonna dimension them to where they're 48 and 48.
You're just doing 48 because you're doing different.
Because I'm always, yes,
Yeah, okay.
I'm always, I have to be a little bit odd.
What about the
Right,
fixtures
right,
though?
okay. Then I get out of the sketch, and then I have to go in and edit this guy, that's this one, and in the group down here, the path segments, I've got to click on these other ones. So in this path segment in your group, where you're defining one of those, you have to pick other segments. And so now I've got 3 segments. And I can say, okay. And I have a beam that's now the same length, but it's broken up into 3 chunks. We buying that? So wasn't that a hard edit? You guys can accuse me of making this model hard because instead of drawing a line, you had to draw 3 lines.
3 times as hard.
It's 3 times as hard. I cannot refute that. However, it doesn't take 3 times as much work in creating the weldments, right?
What was
Because you
that?
just have to add them to the same one.
That last part you did, wait, you have to link that? Or?
No, you just go into you edit the weldment thing, and then there's a weldment on there, and you can edit the feature, and then that'll add to it over here. It's if you, see this thing down here where it says S section 5 here?
Yeah, I'm in my.
If I right click on that, are you out of the sketcher? Okay.
Yeah, yeah.
Okay, it doesn't do anything if you're not out of the sketcher, right? So I've lost count of the number of times I've done that, Clancy, so, okay. Okay, so now we have it over here, we can go back to our beam stuff. Now we've got problems because it looks like our displacement constraint is here instead of out here on the ends. You see the joints, the big balls, we got lots of balls now, so.
It's been a long day.
He's having a hard time. I'm gonna keep using this till he,
I know.
it's the,
I know.
it's
Balls
the,
everywhere.
that's, well,
So we just delete.
I'm really having a struggle biting my tongue here because it can go downhill real quickly. Well,
Don't struggle on my
it's already downhill and going worse, so, okay, we obviously need to change this one here because this guy here is now this reference geometry is now in this position and needs to go out here, so we can double click on him and edit the definition. And of course we want to eliminate this joint and we want to go pick on this joint over there. That was easy. Okay. So we have that one over there. Now we have it fixed at the ends, right? It's all fixed like it's supposed to be, and we have places where we can put loads. Okay, we have sections of the beams we can put loads, so I can come in here and put a force, and now I can pick this beam over here. I'll have to select beam first over here, so it'll pick a beam. I'll pick that one. I'm gonna pick a reference geometry. I'm gonna go pick the top plane, just so I can put the force out of plane. Looks like it's coming up from the bottom. I want to go down, and I'm going to make the arrows bigger because they're not big enough.
So when you added those 3 parts, you didn't have to go back and re-add the material and.
Nope. Well, I will have to go back and rechange the material because it's not gonna know what they are, but that's okay. I will have to do that. And this particular case, I've got 5, I'm gonna go 6,000 pounds. No, I'm gonna go 4,000 pounds. Okay, just so I'm picking numbers at random here. Okay, and I've got that force on there, and of course if I can do it once, I can do it twice. And we're gonna go pick on, again, you have to select on the beam option. To pick the beam, you need a reference geometry, and I typically pick one, oops, that's gonna get me, come on, pick one that gives me an easy way to pick my orientation. I want them to go down, and I'm gonna put, let's say, 6,000 over here, because it's a fun number. We'll make the arrows big. Okay, and so I got 6,000 pounds on this other section over here, and they actually have a per unit length option here that I'm gonna observe because we'll probably need that in the future. So other than that, looks pretty good. We go yes, 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 and I have a load. Okay, a nicely loaded beam. It's constrained, it's loaded. It's taken me a whopping 40 minutes, well, 30 minutes, and most of that was explaining how to get the weldment profiles. Okay? We believe? No, everybody's far too busy clicking. Okay? Or scowling. So, or both. So now what we need to do is we need to go create the mesh, and when we hit the create the mesh button, strange things will happen. Our beam vanishes, and instead
You get the tube.
we get a tube, and that's because
It's being,
it's a beam, and it models everything as a tube, and it goes, I'm not gonna maintain a shape, I'm just gonna give you a blob, okay? A tube, okay? So that's what we have, is we have a tube, that's all it gives us a nice tube. Now we hit run the study, and material is not defined, and that's because of course I only defined it for one section. So we go back in here and apply material to all bodies, yes, okay. And then we go run, and it goes boom, and we have results. Isn't that nice? Okay, I can drag this out of the way over here, I think. Yes, now we have nice results. Looks like we have 40,000 PSI in the center. So it looks like I'm going to yield this particular beam. So am I worried about this? Am I gonna park my car under this beam?
I'll park your car under that.
That wasn't exactly the question I asked. Okay. I think I'm going to, I thought I chose my words somewhat carefully. Are you gonna park your car under that beam? Nope, why not?
Under?
Do you think it's gonna go down? Think it's gonna fail?
You went with the S section, right?
Mm-hmm.
So you used
I
the,
use different loads too, and it's longer. Right? So it's all different than yours, but do you think it's gonna fail?
looks like it.
Okay, how many here think it's gonna fail? How many here don't think it's gonna fail? Okay, got 2. But how many are scared to answer? Okay.
it's, what was the material?
Okay. Or I should say, how many are not scared to answer? Okay, so that's the Well,
What material was it?
A36.
Oh.
Oh,
Yield strength of,
yeah. Right, so it tells you on the bar graph that it exceeds yield strength.
Right.
yeah. Do we believe it?
I don't know.
It's a computer, we don't believe it, right? Okay. Actually, this particular case,
We do.
It's pretty close.
I'm probably inclined to at least take it real seriously, right? Because, heck, first of all, it's over the yield strength, and it's over the yield strength not at a place where it's necessarily artificial.
Right.
It's not where I'm putting the loads on, it's not where I have a constraint, right? It's over strength right over here in the middle, right? Where, you know, away from my displacement constraints and other things. So I'm not thinking this is an artifact of the modeling, right? Assuming my loads were representative of what I want to park on it. See, the 6,000 pounds is probably my pickup. 4,000 pounds is at least somebody's car out there. So we've got my pickup on one end of it and a car on the other end of it, and it's what, a 5-inch? It's a 5-inch S-beam. I think it's unhappy. Actually, I'm surprised it's doing as well as it is, but that's okay, because considering we got a pickup parked on top of it, right? Actually, pickup and a car parked on top of it. I don't think my pickup's gonna go over 6,000 pounds. Might, but I don't think so. It actually probably does. Okay. But not by a lot. So yeah, I'm kind of worried about this. Certainly gonna check it out, but I think I'm kind of worried about this. This looks to me like it's going down. Okay. And we got the stress is, it's not a stress concentration. Stress is uniformly distributed over a whole bunch of things, right? It's not looking good. We can of course do our probe tool, right? We can go figure out where it's bad. It's gonna be bad right about here, right? In fact, I picked it first time. Even got coordinates from it there, right? X location, and of course, you notice these other two are basically, where's it located? It looks like 81.7 inches, and then I have something that says E minus 15, and something else that says E minus 15, which to me sounds a lot like 0. I don't know about you, but I can't measure E minus 15 inches. Can you measure E minus 15 inches? I'm not sure the semiconductor guys can measure E minus 15 inches, though they probably can. But, and they're the biggest animals that are out there. Okay, so anyway, looks like we're doing that, we're seeing this. We're actually looking at axial and bending loads on it. We can, of course, look at there are other things you can look at. You can go edit your definition, and there are other things we can look at. We can look at axial loads, the bending directions, the bending stresses. We can look at a torsional stress if there is one, and we can look at the shear stresses in there. All of those are possible. I'm going to leave the axial and bending in there. It's not a bad thing to look at. Okay. We can also look at the displacement, and it tells me that it's deforming down here over 1 inch. Right. And that's before it starts yielding. When it starts yielding, it's going to be further down than that. Right. And when it starts yielding, guess what? It's going to keep yielding because it's got, I mean, maybe might get a little bit of work hardening, but we're not going to get very much. So it's going down. I'm glad you parked your car underneath it, not me. Okay. So, wasn't that easy? Let's see, what'd you have to do? You had to draw 3 lines. Well, you had to deal with the internet. You had to go download those weldment profiles. You had to go put them in the right place. Okay? Okay, so that's what we had to do. We had to download development profiles, put them in the right place, and then we just had to go pick the right ones, right? But you guys can all do that.
Apparently we can't.
Okay, well, if you can't do it, you can call Brian and he'll explain to you how to do that, okay? So that's,
I'm one of the you guys.
I have to pick on somebody in here, right? So, that's the, okay, questions on this one? Look easy, look straightforward?
Can you show me one more time how you moved the constraint from the first beam all the way to the end? I didn't see that.
How you put what, the constraints on this end of it?
No, when you moved it from the end of the first beam to the end.
Oh, okay.
Sorry.
Yes, that's okay. No, it's easy enough to do. All we have to do is, any one of these, you can edit them, right? You can click on, these are the constraints, right?
Right.
You can edit them. You just right click and edit the definition, and then it'll tell you this is where it is, right? It's right over there. If I want it somewhere else, I can just click on a different location,
Oh, okay.
right? And then I can get rid of that other one by just saying delete,
Okay.
and now I've moved it into there,
Got it.
right?
Simple.
Right? So I can, it's dead easy, right? Because you can only click on the joints, right? It's only gonna let you fix it at the joints.
Okay.
So if you don't have a joint there, you're not gonna fix it anywhere, right? So you better put joints.
Okay.
Now, okay, so, there is another option in here, at least in the past there's been. Let's see. Properties don't give you anything that's that one. Let me see. I think that, no, that doesn't do it either. There's a, somewhere in there's a thing that you can treat it as a solid. And I don't ever use it, but somewhere in here there's a treat as a solid option. They may have gotten rid of it in 18. They come and go with them, right? They come and go, and see, now it's doing weirder things. I'm gonna be happy parking my car under it now, though. Only goes to 29,000, right? So, okay. Does it look good? Does it look like it's supposed to? Looks like a beam, bending, doing weird, twisting stuff? Okay, beams are easy. Now, do we do beams all the time? Well, first of all, when do we do beams? Well, typically it's things that are constant cross-section, right? The cross-section doesn't change. We're not putting holes in them. We're not doing anything weird with the cross-section. We're also typically really only worried about the loads in the beams. We're not worried about, well, we're not going to get information about the places where the beams come together. Okay, so if you're worried about the joints where we're joining the beams, you're not going to get it out of a beam model. Okay? Because it doesn't have anywhere near the detail about what's happening, how the load gets in or out of the beam. It assumes the load magically appears on the centroidal axis, distributed like it's supposed to be. And the fact that, of course, we actually have to fundamentally design things to do that, it doesn't know anything about, right? So areas where all the beams come together, or areas around the constraints like our supports, it's not accurate around those. Now, it's accurate from what the external loads are doing, but how that load actually gets out of the beam has no knowledge of it all. And so what do you have to do? Well, typically if you're worried about that, you run an analysis like this. You find the reaction forces at those locations, which it should give you, right? And then you have to go make a submodel that's a solid model of that local location with the forces and the things on their appropriate locations, and see if it actually does what it's supposed to do. And it's easy enough to do. I would typically, if I was worried about the ends here, what I would do is like this end over here. What do? You find the reaction forces over here, and then you move over a little ways and you model it as a beam with whatever your supports are, and you put the loads on the beam as they go, and you just fix this as a cantilever, because you don't really care about what's happening out here. Out here where you're gonna fix it as a cantilever, right? You already know what the stresses are from this analysis. Right, so all you're doing is fixing it and trying to figure out what the stresses are as from that are applied at the immediate location. And that one's where you have to model it as a solid, or at least shells. And I would probably model as a solid these days, it's easier. Though I don't know if the answer, I don't think the answer is as accurate, but it's easier. So it's just, okay, we'll do it as easy way. Does that make sense? We do a lot of that little sub-model thing where we get an idea of what's going on here. And then if we want to really worry about what's happening here, how am I getting the load out of the beam here? Well, I'm going to have to model that separately. Right, I'm going to have to make up a separate model of that. And typically, rather than put displacement constraints on it, I'll put the forces on it, right? The way the reaction forces are, just hold on to the end because I don't really care, right? That's the thing that I'm really worried about, is what the forces are on the ends of it. Okay, making a little bit of sense. You know, little sub-models like that, and these happen all the time because much of the time what we do is we make space frames, right? We take constant cross-section stuff and we weld them together, right? You've seen my nightmares. Other people are building theirs out here. Have fun projects. They're going to be building theirs, right? Their space frames, and so what do? We model them as space frames, right? It's a perfectly fine thing to do. We build a lot of space frames. It's an easy way to model. Just don't trust the results at the joints, because they're not accurate at the joints, right? The joints being where multiple things come together. If it's just a joint by itself, like this one out over here, that's perfectly fine. I don't have any problem with that, right? It's the way it's going to be, right? There's nothing else there, right? But when I'm coming over to this location over here or this location over here, I'm gonna have to have structure there. I'm gonna have to have something that's carrying the load, right? I don't just get to have it magically jump off the beam onto the side. It actually has to go through some structure. And frankly, that's a lot of times where they fail, is at the connections. Okay? It's getting cold in here, isn't it?
Not bad.
Someone's getting carried away with the air conditioning.
Didn't do it.
Who did that? Who did that? Sarah. Okay, questions on this one? No, you got it good. Okay, so I'm gonna go file, close. Do I wanna save? No. Okay, so we get this next one, which you're all familiar with. You know well. You have cantilever beam, and it's a rectangular section, right? So, and we're gonna make it out of aluminum because I feel like it. Okay?
Are we supposed to do our homework?
What are we doing different
No.
on this?
Nothing,
Oh.
Well, but
except we're modeling it as a beam instead of modeling it as a
So,
Rectangle?
solid. Last time we modeled it as a solid. Right? Now we're gonna model it as a beam, and you can compare the results between the two. Right? As well as your manual calculations. I usually don't put this one in here. I usually put a different one in. But I changed it just to try to let some of you catch up. Okay, so you don't have to do another set of hand calculations because you've already done them. Doesn't that make sense?
Okay.
Okay, so we get to model this one as a beam. Okay, so now there's a problem with this. Just a minor problem, but there is a problem. And that is that when I go and dig in my cross sections, I'm not going to find a 4 by 1 1/4 rectangle.
oh, that's where the custom comes in.
Right? It's not. It's not in there, right? And this happens all the time, right? We get shapes that aren't in the library. So what do?
Something else?
We build our own, right? Okay. Are we excited?
I
I am. We
Okay,
can't
good.
download
There we
a-
go.
A rectangular channel?
No, they don't actually make rectangular channels, so it's just a rectangle. So what we do is we're going to go make ourselves a rectangle. So File, New. Okay, and I got a new part here. And again, we're going to do this is hard modeling here. I'm going to sketch on the front plane. Okay, and I'm going to go get rectangles, and I'm going to actually get a center rectangle so that I define the center point. Yeah, go away, you annoying POS. Okay, and so I'm going to make myself a rectangle. I click on the origin so that the thing is centered, and you definitely want to click on the origin because it's going to build the origin as the centroid is going to be the shape on which the line, it's where the extrusion line is going to be, the perpendicular line that's going to grow it is going to be on through the origin, and so you can pick it with wherever you want it to be. So anyway, I'm going to dimension this thing here now because I feel like it, and I'm going to make it 3 inches, and then I'm going to make it 1.125. Okay, so I've got a perfectly fine rectangle here, that 3 by 1.8 inch rectangle, and now I'm going to save it. And so I'm going to do File, and I'm going to Save As, and I'm going to stop here. Well, I'm going to name it something nice like 3 by 1.125 rectangle. Okay, but I'm not going to save it as a part.
Did you exit
You
the
save as a
sketch?
program.
I did not exit my sketch,
Okay.
and I'm going to need to exit my sketch or it's not going to work. So
And now we save it, or?
I'm going to have to save it after. You have to exit your sketch first.
Oh, okay.
Okay, you have to exit your sketch first or it's not going to be happy. So I get to do it again, right? Now, and I'm going to do, okay,
Save there? Design library?
3 by, I'm going to just let it go 1.125.
Should we have that same path?
Just
Oh.
a second. All right. Okay, and I'm going to save it as a library part here, a lib feature part here. This one here, the second choice down. Going to save it as a lib feature part, library feature part. Okay. Okay. Now, questions are asked. Do I want to save to this long path? Program data, which it doesn't actually show, but it's SolidWorks. Well, I think it's program data, SolidWorks 18 design library Weldments. It's as good a place as any. Okay? You're gonna have to go move it anyway. Okay? I don't really care where it saves it at this point, as long as it saves it somewhere. Okay?
Where's program data?
Oh, yeah, well, we get to go find that, right? Okay.
See, there's SolidWorks data.
Okay, so, I'm just gonna go save here because it feels like it, and it goes, I put it in Weldments.
I don't have a Weldments one.
You don't have a Weldments one? I think I actually built one that was Weldments.
Okay.
So I might have done under design library, I might have done in fact, I'm sure I did because it's a capital letter there, right? I did the new folder thing, Weldments, and said save. Okay, now I get to go find that, which is under some nice place, right? Like, well, where the devil did we put it? Okay, so here we go all the way back out, and at my first level, local disk C, I have program data. I'm at C, I'm at level C, right? I have program data, and I've got program data for all kinds of things, and I got SolidWorks, and I got SolidWorks 18, and I have design library, and I have Weldments, and there's my goodie. 3 by 1.25 rectangle. Okay.
Program files?
Where's your program data?
It's a C.
C program data?
Yeah, but
C program data.
I don't have
it's
it.
not the same as program files.
Correct.
I
It
mean-
is a different folder.
It's a different folder.
I don't have that.
Well, then look at your path when it saved it. Go ahead and try to save it again and look at your path and see where it put it. Because if you try to save it again as a feature part, it will try to put it in the same directory it was already in there. Right, so you can go back to here and go, right, file, save as, and it'll give you that path up there, right? It'll give you this path. So if yours doesn't have the program data file, it's got something else, or maybe it made that a hidden directory.
How do you,
I go unhide all mine. I don't know if it's, does yours say program data like this?
it says program data when I try to save it, but I don't, how do you unhide?
Um,
Up at the top in the file explorer,
I think it's over here, yeah.
you should have an option to view hidden folders.
Do you have programs?
If you go C drive, yeah, I think you can, I think you can, isn't it even in the C disk, can't you go, there's a,
No, if you go to, you have to go to the view menu.
there it is, right, see, isn't there a properties here? I can do C
Yeah, you can do
properties,
that too.
and then, C properties, what is it, tools?
Yeah, so
I mean, it's security,
the quickest way to get to it is just the view menu.
okay.
Yeah, up at the top.
What, just here,
So all the way at the top,
Yeah.
right next to
Okay.
manager, so you got home, share, view, and manage.
or? Oh, okay,
So
view,
if you go to view,
To the right.
Okay.
Yeah, so you have it
Hidden
checked,
yeah,
items.
yeah.
items is checked.
Okay.
yeah, hidden items is checked, yeah,
Yeah.
yeah.
Thank you.
Okay, okay. Sorry, you guys, that's again, there's the IT guys, right? That's
Where was
okay,
that again?
okay. Under C, you go to C and then do view, and you'll have to check hidden items because apparently it hides it. So, okay, okay. Hey, I go through intentionally, and I don't ever remember doing it, but I go through intentionally and always make sure it shows everything that's hidden. I hate having things on my computer I don't know are there.
Yeah, why would,
It's
it's weird.
they're trying to protect you from yourself. So, okay. So anyway, where this stuff is again, if we go to the C directory, I'll get out of here, right? We go to the C directory. It's under the program data, SolidWorks 18, design library, and then we have weldments, and we have our goodie here. Now I just right click on this and say I want to copy it. And then I get to go play the game of go figure out where I really want to put it. And I want to put it in C I want to say C program files. Okay, back down to SolidWorks Corp, SolidWorks, language, English, weldment profiles. And now, when you guys come in here, you need a place to put it. And so I, of course, went new file. I went, new folder, and made a new folder, and I made one that said custom. Okay, and so if I click on custom, and then I just copy it, paste it there. Okay, it goes, do I need version? And I go, yeah, no problem. Put it in there. So I put it in under custom. Now,
That's where it is.
okay, so I have saved it over at a place that's convenient for me. Cancel over out of here, right? Now I'm gonna do a new model here, part, okay? And I'm actually gonna get rid of the old one because I don't really need this one. And I don't even want it around. File, close. Okay, so I have this new one here. I'm going to get the front plane. I'm going to go sketch. I'm going to draw my nice line, right? Which in my case, I'm going to be smart, and I'm going to know I'm going to need to draw 2 lines because I've got sections of the beam in there, right? And I'm going to dimension this, make this one something like, 70, no, let's make it 50 inches. Okay, And then I'm going to make the next one, come on. Oh, come on. Escape. Where's my other line there?
Did you go over it? Or did you
Yeah, it did. I think it went over it. Where is the other line? Oh, it's over here. What did I do? There's another one here.
Yeah.
Okay. Yeah, I don't want that dimension there. Delete you. Okay, I want you. Escape. I didn't want you. I just wanted you.
Yeah, it made that one go on
Over the top, but
yeah.
and didn't give me the other one. That's mean of it. Okay. Well, fine. Be that way. Okay. Quit. Go away. Okay, there we go. I can be ornerier than SolidWorks is. It's the okay. I've got 100 inches of beam here, which I'm going to say is close enough. Okay, and I can exit out of the sketch now. And I'm smart on this. I go, okay, I got my axis. I can go insert weldment, structural member. I'm going to come over here and do custom. And when I go to type, I'm going to do, gives me rectangles, but doesn't give me the one I wanted. And in fact, no, it requires 2 levels of directory, which is why I had to build the rectangles one first.
What if you don't?
So what we have to do is go grumble, grumble, grumble. We copied it in the wrong place. We get to go back to our weldments thing here again. Okay. Where we have our weldment profile and our custom, and you're going to have to build another directory in here, make another folder that's under the custom one that is in my case rectangles, and I'm going to move that one into there. It's going to ask me if I want to do that. Oh, it's not open in SolidWorks. You'd love SolidWorks,
You
wouldn't
have
it?
to exit out of here.
It's probably out of this guy, right? Yeah. Okay, probably out of that one. That may make it happier. Cancel. Okay.
So you just have to make another folder.
Yeah, no. Okay, let's see if I can't make the copy work. Still annoying me. That one right there. No, it still hasn't made the copy work. Wrong directory. Custom. Okay. I want to copy you, and let's put it in there. Paste. Continue. And now I have 2 of them in here. One that's 1.5 by 4 and one that's 3 by 1.2 by 5. You can tell I'm not consistent on how I label these. Okay. Anyway, I have 2 of them in my directory that's rectangles, which is under my custom folder, and you're going to need 2 levels of directories because it needs 2 levels or it's not going to give you. So the file that you created, the library feature part, needs to be 2 levels deep under after the weldment profile one, because there's 2 tabs that you're going to have to pick, right? You're going to have to pick, in this case, we're going to have to pick a rectangle one underneath our custom one, right? We make our custom one, and then we're going to have to make another level of directory to where we have a directory tree. So it's going to require, as a format, 2 levels of directories, right, for their selection tree, and they're going to build their selection tree out of the file folders. Does that make some sense there? Okay. And that's why I go through it, is we have a little discussion of just what they're looking for and how how they want to do it. So now when I want to make this a profile, I can select on this. I can go insert weldment. Let's try it again. Insert weldments, structural member. Now I should be able to go to custom, pick on my rectangles, and down here I should have my 3 by 1 1/8 rectangle that I made. I put that one on there. I pick a group, but I'm going to pick that guy and that guy there. I look at them to make sure, and the darn thing's laying flat again. So I'm going to make it 90 degrees down here in the bottom. And now it's standing up on edge, right? Just like we wanted it to. We good with that? Okay. Okay. And so now we've got that, and of course we can make this, and then we just say, okay, I got a beam. So now I will claim this one simpler because we only had to make 2 lines. Oh, and we actually had to make the rectangle, which required 2 mouse clicks.
Couldn't be any easier.
It required more than 2 mouse clicks.
Okay.
I'm just trying to get.
Well, now 2 mouse clicks to make the rectangle.
Okay, but then you have to constrain it, right?
Then you have to dimension it, right? All you have to do is dimension it there. So that's.
Then you have to save it.
Then you have to save it.
Exactly.
Oh well, then you have to. Well, then they're okay. There's all the other things. So, okay, well, you're going to get.
Carpal tunnel, man.
Okay. Your story touches my heart. Okay, so we're going to do a new study here, just like we've done before, and we're going to do. Okay, and I'm going to say statics. We've been doing statics all the time. Okay, we're going to go assign a material here. I'm tired of steel. Let's go do aluminum. Okay, you guys got a favorite aluminum?
70, 75, 60,
70, 75,
61-0.
60, 61.
Yeah, T6.
Which one are we saying?
50 T4751.
Okay, you guys got to be. I'm not going to buy it in the O condition, first of all. Nobody get.
Aluminum.
7451.
So let's see.
61, T6.
60, 61, T6. Okay. 60, 61, T6. I can do that. Okay. Okay. So now we're going to go constrain it, right? And this one we can do fixed geometry, and amazingly enough, we really can come over here to the end and say I'm going to pick on a joint, and just pick on that one, and it's just done. Okay, right? It's just fixed, right? And we're picking the joints, right? It's fixed as it can possibly be. We need some loads, right? So I'm going to put forces on here. Now I put forces, right? And I'm going to put them on the beams. So I'm going to put one on that one, and I'm going to put one on that one. And then I need some orientation, and again, I'm going to pick the top plane here so I can pick the out of plane direction. It's going the wrong direction. That's what it does. Always goes the wrong direction. Make the arrows big. Big arrows, I'm going down. How much do I want now? Well, I'm going to go per unit length because it's good, but I got inches. And so I had, say, let's say, 2 pounds. 2 pounds per inch. Okay, that's close enough. Okay, so what I have is a distributed load here, 2 pounds per inch, right, on these 2 things. Okay, and that looks pretty good. Then I'm going to go through and put another load on. My force in this particular case, I get to pick on different things, but I'm going to put it on a joint, and I'm going to put it on this joint right here. I again am going to pick some nice reference geometry like the top plane so I can pick the out of plane stress, direction. I see it again coming up from the bottom because they're stupid about it. Okay, so I get my big arrow coming up from the bottom. I want it going the other way. I want it going down from the top. And I'm gonna put about, what, 250 pounds on it? Because it feels good. Okay. And so now I have a force here that I can click on and a force over there, right? I'll go back and forth, right? See which one's which. Looks pretty good. I'm almost done. Go create the mesh. Boy, my beam magically vanishes and I get the big tube. And then we go run the thing and it bends. Okay. Right, it looks like we have 13,000 PSI with the yield strength of almost 40,000 PSI. Gonna park your car under it?
Yes.
Okay. Okay. So now I would ask if you're going to park your car, your spouse's car underneath it, but I'm not sure I want to know the answer.
Depends, is the spouse in it?
Yeah. Ooh. I thought we were down pretty low with big balls running in here, but this is
been that kind of day.
it's I was gonna say this is now there's a I think someone who's recording this can have some extortion material here for Brian, right? So when you need to get him to help with your computer, I think you can say I did record that, right? So, okay. And so now we can, of course, get the stresses in this, and again we can look at the displacements, and the end it looks like it's deflecting down 2 inches over here, right? They do look like kind of they belong, right? We get the maximum deflection over here, just like we expect. So,
I did see that.
so, okay. Questions on that one?
So much.
So many questions?
Yeah.
No, you can't have that many questions.
I'm gonna go over the video again about how you did the profile, because we were still messing around with the
I can show you the
development and
profile.
stuff.
Can I
Yes.
see it?
So,
What's that?
Can I see how you do the fix? For the first, what feature?
It's just fixed geometry, right? Just to do the fixed geometry. So if we want to do the right, we want to do the fixture, we just go to fixed geometry here. The top fixture, fixed geometry, and then we just fix it, right? It's cantilever. It's cantilever, right? You should.
I have like, I have 3 points.
It requires a joint.
I have 3 points. You
or
only
3
have one.
arrows. I had 3 arrows.
Yes.
Going towards
Is it 3 arrows?
Don't you, Will? You want to pick fixed geometry.
We did.
Then it's fine, yeah.
He's got 3 arrows.
You have 3 arrows, but you have 1 arrow.
No, I got lots of them. They're on the other side. There's one on the top here, and there's one on that one.
Yeah, green one is in the weeds.
So I'll try to give you.
So-
And I'll send you the link. So you should be able to. So last week,
Yeah, that's what it's for.
I'm trying to make sure I get this.
So what do we save the cross section as? For some reason I can't seem to.
Library feature part. See?
No, I've got.
See, I got lots of arrows there. I got big arrows there.
Yeah.
Right? What's that?
I think one of my, is it weird if one of the arrows is
No,
on the bottom?
no. Just an orientation.
Yeah, no problem.
Right? Just an orientation. Okay?
That seems good.
Okay?
Just draw 2 more lines.
I like this.
Good. Yes, what's the tricky part about this whole thing? Where to put the darn stuff. And how to put it, right? That's the hardest part. What to save it as and where to put it, right? Right? What to save it as. all the profiles have to be saved as a library feature part. And you have to get out of them before SolidWorks will let you copy them around. Okay, because otherwise it thinks you, so you have to create them someplace and then exit them out of SolidWorks before it's happy with letting you move them around. But then you can copy them, and you need to copy them into somewhere in the, under program files, SolidWorks, then it's the language, English, weldment profiles. Okay, which is a long way to get there, right? But you'll eventually figure it out. And that's the hardest thing to remember is the past, where they put the darn things, because they hide them so well, right? Where do they put the profiles, and because they don't tell you, right? They don't tell you where they are. And I only find I forget every year, and so I go through all of the word things that are SolidWorks. And the thing you have to remember is it's going to be under Lang English. Okay, that's the one I remember. Okay, I go, oh, SolidWorks. Oh, here's one that says Lang English. It goes down and there's no profiles. Okay, it's not this one. I go find another one. And then I dig through them all. And I wind up digging through them every time because I forget where they are. And then you go, okay, I know it's in one of these, and eventually you find it. And you can always tell when you got the right one because the directory structure will match what pops up when you try to create a weldment. Right, they'll have the same names and same numbers, and you'll be looking. It's like you're looking at the directory structure when you pop up create a weldment. Right, the pull down menus that let you choose will be the same names as the folders under the weldment profile one. Okay. And they have put weldment profiles in multiple places, but SolidWorks is only going to look at them in one place. So you can find them in other places and they won't work. And the way I identify them is when I try to create them, this is not the right one. So it's still getting cold in here, isn't it?
Yes, it is.
Balmy 70 degrees.
Oh, it's warm outside.
Yes. One might think it was summer. Okay, good people.
Time to go home.
I'm good. Are you guys good?